Hello everyone, in this video I'll be explaining you the problem minimum subarray length with distinct sum at least k. So this was asked in biweekly contest 173 of Leetcode. So let's read out the problem. You are given an integer array nums and an integer k. Return the minimum length of a substring whose sum of the distinct values present in that subarray, each value counted once, is at least k. If no such array exists, return -1. Okay, so we have 2231 and k is 4. So let's take this example and go to the board. So we have 2231 as the array elements and k is 4. K is 4, and then we have 2231. So in the example, what they've said is we have given nums array. Okay, so and they've given k. So we need to find minimum subarray. Okay, minimum subarray such that all unique values in that subarray, all unique sum of all unique values in that subarray should have a value at least k. At least k. So I think you've understood, right? So what they're saying is, first let's try to see in this example and see. Let's try to figure out how many subarrays is possible. Now you take 2 as one of the subarray, then you take 2 comma 2, then you can take 2 2 3, then you take 2 2 3 1. Okay, 2 2 3 1. This is the subarray starting with 2. Starting with 2. Let's try to find subarray starting with this 2. Starting with 2 presented index 0. Okay, now I'll take one more starting from here 2, then we have 2 comma 3, then we have 2 comma 3 comma 1. Okay, so this is also starting with 2, but its index is 1. Now I'll take starting with 3 comma 1. So this is starting with 3 whose index is 2. Now I'll take starting with 1, we have only one possible, its index is 3. Okay, so now if you try to see, its sum is 2 only. Okay, but it's not greater than equals to k, right? So this is not a valid. This sum, if you see, it is sum is 2, it is not 2 plus 2, because you will have to take unique elements. So in this, unique is only 2. Okay, so we are taking 2. Again, this is not greater than equals to k. Now if you take here, the sum is 5. Okay, 2 since 2 is counted only once and 3 is one time, so 2 plus 3 is 5. It is greater than equals to k because k is 4. Okay, so now its length is 3, so we can consider this, but let's see if we have others. So if you see here, sum is 6, 2 plus 3 plus 1, which is 6. Again, it is greater than equals to k, but we have got already optimal, like its length is 4 but its length is 3, so this one we are taking. Now its sum is 2. It is not greater than equals to k, its sum is 5. Okay, and which is greater than equals to k, k is like 4, so this one is not optimal, right? This is 3, this is its length is 2. They are asking you need to find the minimum length subarray. Okay, minimum length subarray. So yeah, this one is looking like valid. If you see, its sum is 6 but its length is 3, so we have already got 2, so we are not taking this. Now its sum is 3, it is not equals to greater than equals to k. Its sum is 4, it is also greater than equals to k, right? Greater than equals to k, and we have already got 2, so its length is 2 only, so this is also optimal you can think of, but answer is 2 only. Here sum is 1, so it's not. So I think overall picture I've got here, right? So how do we solve this? But if we try to see what is happening, you are starting with 2 and taking all the things, right? Okay. So in a brute force, if you try to do it, what will happen is you need to take one pointer at this position, starting at this position, and now you need to now you need to start from this. You need to iterate till end, and whichever element is unique, only those sums you'll have to take. And if sum is greater than equals to k, so let's say you are at this position, okay, so the length will be j minus I plus 1, right? Okay, if you take 0 to 2, so its length is 2 0 plus 1, so it is 3. If you say 1 2 3, so brute force I'll not be doing because your n is 10 power 5, so n square means it is going to be 10 power 10, which is way greater than 10 power 8, and this is going to give you TLE. Now let's try to do it in some other way. Now what I'll try to do is I'll try to take one left pointer and then one right pointer. Okay, now I'll take one sum variable which keeps what is the sum right now. Initially it is 0. Okay, so now what I'll do is I will make a right pointer to point this and take some the value which is 2, and I'll move this right pointer to forward. Okay, and before moving, what I'll do is I'll try to compare this sum with the k. If sum is greater than equals to k, it is not. And I'll take one answer variable. It is initialized to some larger value, 10 power 9 you can think of, or you can think of int max. Okay, let's take int max only. I'll write im int max. Now when I'm this position, I will try to take this sum also, which is 4. It will not be 4, sorry, the sum remains 2 only, because the values are same only, right? 2 and 2, so only one value will have to take. Again, this sum is not greater than equals to k, so you'll have to not take answer. Now I'll move forward. When I'm in this position, now what is happening? This is unique element, so sum is going to be 5. 2 plus 3 5. Now sum is greater than equals to k, so now you need to check the length. Length is r minus l plus 1. It is going to be 3 here. So which is minimum? 3 is minimum. I'll update 3. Okay. So see, now the thing is your sum is 5, right? They've asked your sum has to be at least 4. Now if you try to take the next element, your sum is going to be 6. But what do you need? Because if you take the next element, it is simply going to increase the length, right? Since you have got already length which is greater than equals to k, so why you need to add one more element, right? Also in the question, if uh, yeah, like all elements are positive only, if it is not negative, so it does not make any sense. But even if it was, let's say, negative also, so in that case you have already got a sum whose length is this, but when you are adding negative, sum is going to decrease, and your length is going to increase. It is not be optimal. So that's why even if it is negative, it does not make any sense. So see, you have understood, right? So you have got the sum as greater than equals to k. Now if you try to add something whose sum will increase and then length is going to increase, so we need to find the minimum length. So instead what I'll try to do is, when my sum has got greater than equals to 5, so I will try to reduce my sum in order to make sure that my sum is less than k, and I'll get the answer like minimum. So once my sum is greater than equals to 5, I'll try to move this left pointer. So now I'll move this left pointer ahead. When I'm moving left pointer ahead, which means I had this subarray now, okay, and sum remains 5 only. The reason being is because there were two elements of value 2. So one is went. So in this, if you see, the distincts are 2 and 3, so that's why sum is not going to change, and sum is not changing. But if you see length, it is 2 now, okay, it is 2. So among 2 and 3, which is minimum, 2 is minimum, so I've taken this, okay. And sum remains 5 only. Now again I'll move this left pointer ahead. Now my sum is going to decrease by 2, so it is 3, because if you see, we have just one in a subtree, we have one element whose sum is 3, and sum is 3 means it is not equal it is not greater than equal to k, so you are not calculating the answer. Yeah, this is now we'll move right pointer ahead. Now your sum is going to be 4 and it is greater than equals to k. So if that is the case, then we need to check length. Here length is 2 again, so which is correct only. Now since the sum is greater than equals to k, so we need to move left pointer ahead. If I move left pointer ahead, now your sum has to be reduced by 3, right? Okay, so it is reduced by 3, so it is going to be 1. Now your sum is less than k, so you need move right pointer ahead, so you don't have any element, stop the simulation, and you have the answer is 2. But the thing is, how do you keep track of the unique elements, right? So for that, what I'll try to do is, I'll try to take a hash map, or map you can say. This will be unordered map only. Initially sum is 0. My answer is int max, right? So it's a 2-pointer approach problem, okay. I think you have understood. So see, initially my right is here and sum is 0, so I'll take this. Your sum is 2 right now, okay, and I'll see if this element is present in the map or not. It is not present, so 2, its frequency is 1. Okay, and since sum is not greater than or equals to k, so we are not checking the answer. I'll move right pointer ahead. Before adding this element to sum, I'll check if this element is present in the map. If since this element is present in the map, so I'll not add this sum, because which means 2 is already added in sum, so only one time we'll have to add it, so second time I'm not adding, but I'm increasing its frequency. Its frequency is 2 now. The reason why I'm increasing its frequency is that we need to keep track of how many 2's we have taken, okay. When you move left pointer ahead, so when you remove these 2, so we can reduce the frequency and it will indicate we have only one 2. So we have done this. Still sum is lesser than k, so we are not increasing answer, we are not updating answer, we are moving ahead now. We'll check if 3 is present in the map or not. 3 is not present in the map, so if 3 is not present, you add to the sum, so you are adding 3, so it is 5, and you place into the map. Its frequency is 1 now. Now your sum is 5, which is greater than or equals to k. Now you calculate the length. Length is 1, 2, 3, right? R minus L plus 1 if you do, which is 3. Minimum of int max and 3 is 3. So my length is 3 right now. Okay, so my sum is greater. So as I said previously, you don't need to take other, because if you take other element, so simply it will add sum to it will add to the sum, and then the length also will increase. So that's why you need to make sure keep your sum to the lesser than k. So I'll move left pointer ahead now. If I move left pointer ahead, uh, first when I'm moving left pointer ahead, I'll decrease its frequency to 1. Okay, because 1 is gone. It's like we have this as a subarray, and 2 is one time, 3 is also one time. Okay, so now since only the frequency is reduced, right? That's why I'm not decreasing the sum here. If it were like frequency went to 0, which means that element is not present, so that element we need to remove from the sum. Okay, which makes sense. So now again, sum is 5 only. Okay, now I'll calculate length is 2, 1 2, so it is minimum. Now I will move my left pointer ahead. When I move left pointer ahead, your frequency went to 0. If it went to 0, which means it is no more element in my subarray, I'll remove this. When I'm removing this, I'll have to remove 2 from the answer, which is 3. Okay, so as you can see, we have this as subarray, its sum is 3, which is correct, and we have only 3 as frequency 1. Okay, now you move right pointer ahead, you have 1 is not present here, so add 1 and its frequency is 1. Answer is 4. Right, now sum is greater than equals to k, so in that case uh, you need to check the length is 2, which is already maximum, so move L ahead. When you're moving L ahead, its frequency is went to 0. When it is 0, which means this element is no more, so you reduce 3, so it is 1 and remove from the map. Okay, so now it is correct, right? It's like one length subarray we have, whose sum is 1. In the map we have 1 and its frequency is 1. Now since sum is lesser, now you move right pointer ahead, you don't have any element, stop. So whatever answer you have got, you have in this thing. So it's a 2-pointer approach. When you read the problem, you will understand it's a 2-pointer approach. So here we are solving using map. So let's try to code it up. I think you guys have understood, even if you don't. So while coding also I'll tell you. So I think this will be clear. So first thing first, I'll take answer as int maximum. I'll take n as the size of the vector vector nums. I'll take left pointer initially 0, right pointer initially 0. I'll take a loop which is running from where your right pointer has to be lesser than n. I'll also take map. Not on map, why I'm taking, because we need to optimize it, right? Because its retrieval is like O of 1. If you take order, it's log of n. In worst case, it is O of n, but yeah, let's take this. I'll take some variable initially 0. I will check if the in map the element what we are inserting, right, nums of right, if it is equals to mpp dot end, which means we don't have element in the map, that element, right? If we don't have that element in the map, then it's like it's a unique element we are adding into the sum. Okay, and once we add it into sum, now we need to make sure increase the frequency of that element in the map, right? Now while we need to run if sum is greater than equals to k, so which means we have found the answer. Once you have found the answer, so we'll have to make sure your answer is minimum of answer comma right minus L plus 1. Now you make sure move left pointer ahead. Okay, so you need to check the frequency. If I mean decrease the frequency of nums of left. Now we need to check if map nums of frequency, if it is equals to 0. If frequency is 0, which means that element is no more in my subarray. So we need to uh, reduce the sum by nums of left, and you can erase that element from the map. Okay, now move left pointer ahead, and here you need to move right pointer ahead. Whatever answer you have got, you just return it. Let's try to run it. It is getting accepted. Let's try to submit it. Okay, one thing I'm missing. I got what did I miss? See, they have said if no such subarray exists, we need to return -1. So whatever if there is no array, we need to return -1. So we have initialized answer with int max. So if my answer is int max only, if my answer is int max, which means I have not got the array length. Okay, so in that case we need to return -1, else we need to return the length of the subarray. So let's try to submit it. So yeah, it got accepted. So if let's try to analyze the time complexity. So this right pointer is moving from 0 to n, and then this left pointer is moving from 0 to n. So it's like in the worst case, this loop is running till 2n times, and if all elements are unique, then like if k value is large, so in that case you will be storing entire elements. So it's like in worst case space complexity is linear O of n. So yeah, thank you guys for watching the video.